Z transform topic. So today also we will discuss about a few more Z transform topics and LTI systems. So if you look at this question, a linear discrete time system has the characteristic equation z power 3 minus 0.81 z is equal to 0. They've asked you whether the system is stable, marginally stable, unstable. Stability cannot be assessed from the given information. So here a characteristic equation has been given to you, and from this characteristic equation you're asked to find out whether the given system is stable or not. What is it? So what we'll have to do is, first of all, to determine whether a system is stable or not, we will have to analyze its poles. So solve this characteristic equation and get the poles of this particular system. So once we arrive at the poles like this, we will be able to guess whether the system is stable or not. For any system to be stable, all the poles should be within or should lie within the unit circle. So if the poles lie within the unit circle, that is, if they have values between -1 and +1, which is ideally a unit circle of radius 1. So in that case, the system is called to be a stable system. Either ways, it is called as unstable system. So taking this characteristic equation, we try to solve it and get it into poles. So we make it as z into z square minus 0.81 is equal to 0. So this yields the poles as z equal to 0, z equal to 0.9, and z equal to minus 0.9. So now if you analyze the poles, anytime these poles are within the value range -1 to +1, meaning these poles are lying within the unit circle. So hence, this system is a stable system. So all the poles are inside the unit circle. So the system is stable. Next question. The Z transform of a signal is given by C of Z is equal to 1 by 4 Z inverse 1 minus Z power minus 4 by 1 minus Z inverse whole square. You are asked to calculate its final value. So the Z transform is given and you're asked to calculate the final value. So this again we are going to make use of one another property of Z transform. So yesterday I told you like how you will have to prepare for signals and systems questions, meaning as far as Z transform is concerned, make sure you memorize all the standard Z transform as formulas. Make sure you also memorize every property of Z transform, because that we could use it directly to solve the problems. So here they are asking you to calculate final value. So we will make use of final value theorem of Z transform, the one more property of Z transform. So the final value theorem states limit n tends to infinity, x of n is equal to limit z tends to 1, 1 minus z inverse x of z. So this goes to be the formula for final value theorem. So using final value theorem, we will be able to calculate the required value. So what you'll have to do here is, here it is given as x of z. So in your question, already c of z, meaning the z transform of the given signal is given. So substitute this value in this z transform. So when you substitute, you get it as limit z tends to 1, 1 by 4 1 minus z inverse, z inverse 1 minus z power minus 4 by 1 minus z inverse whole square. So once you solve this, you have 1 minus z inverse and 1 minus z inverse whole square here. So these both get cancelled and you get it as 1 minus z inverse. So the numerator remains the same. The numerator remains the same. So next, what you'll have to do is uh, every value is in terms of z inverse. So convert all the values in terms of z. So once you convert it in terms of z, your final value becomes z plus 1, z minus 1, z squared plus 1 by z power 4, z minus 1. So substitute the limit value z as 1. So when you substitute, so you get the value as 1. So your answer for this problem would be 1. Now, if the impulse response of a discrete time system is h of n is equal to minus 5 power n u of minus n minus 1, then the system function h of z is equal to. So for this particular question, they have given you the impulse response of the system h of n. They are asked to calculate the system function h of z. Also, they've asked to calculate whether the given system is stable or unstable. So h of n is given, h of z is asked. So simply you will have to take z transform for the given function. So this is a standard function which we already know. This is of the form minus a power n u of minus n minus 1. So solving that, we will get given is the impulse response h of n is equal to minus 5 power n u of minus n minus 1. So this is a left-handed signal. So its z transform will be of the form 1 by 1 minus a z inverse. Simply you can call it as z by z minus a. So since it is a left-sided signal, the ROC z modulus will be less than a. So simply apply this particular standard expression to the given impulse response in the question. So we will get it as, your A will be 5 in this case. So you will get it as 1 by 1 minus 5 Z inverse, and your ROC will be written as modulus of Z less than 5. So here we have calculated the H of Z as asked in the question. So next thing what we'll have to do is we will have to find out whether the given system is stable or not. So 1 minus 5 Z inverse can be otherwise written as Z by Z minus 5. So the correct answer would be Z by Z minus 5. So the options would be B or D. Next thing we will have to find out whether the given system is stable or unstable. Now, to find out whether the given system is stable or unstable, you will have to analyze the poles of the transfer function. So what is the pole here? You have it as z by z minus 5. So the pole here is, the ROC here becomes z less than 5. So if it is modulus of z less than 5, you will have to check whether your ROC is including the unit circle. So if your ROC is including the unit circle, this is another way to find out whether the system is stable or not. So in this case, it is modulus of z less than 5. So minus 5 to plus 5, there will be a circle, meaning this is a circle of radius 5. So circle of radius 5 means definitely this will include circle of radius 1, which is unit circle. So therefore, the system is stable. So this is another way of analyzing whether the system is stable or not. Next, the Z transform X of Z of a sequence X of n is given by X of Z is equal to 0.5 by 1 minus 2 Z inverse. It is given that the region of convergence of X of Z includes the unit circle. The value of X of 0 is. So here you are asked to calculate the value of X of 0 given is the Z transform of the function X of n. Which is 0.5 by 1 minus 2 Z inverse. So what we will do here is, Now, given x of z of a sequence x of n, so x of z is equal to 0.5 by 1 minus 2 z inverse. So this is a left-handed sequence with ROC as modulus of z less than 2. So Z transform is given, ROC is given as ROC is given. So whereby we analyze that this is a left-handed sequence. Left-handed sequence means we will have to give it as u of minus n minus 1. So comparing it to the standard formulae, we get it as a minus 0.5 to power minus n u of minus n minus 1. So we have got x of n here. In the question, they have asked you to calculate x of 0. So to calculate x of 0, simply substitute n as 0 in this given expression. So substituting n as 0 in the given expression, your value will be x of n is equal to minus 0.5 to power minus n u of minus n minus 1 will yield the value as 0. So your option would be 0. Now, next question. A system with transfer function h of z has impulse response h of n defined as h of 2 is equal to 1, h of 3 is equal to minus 1, and h of k is equal to 0. Otherwise, consider the following statements. Yes, 1, I mean statement 1. H of Z is a low pass filter. Yes, 2. H of Z is an FIR filter. Which of the following is correct? Now, what they've asked you to do here is they have, I mean, there is a system with transfer function h of z and its impulse response value h of n for three of the values are given here. H of 2, H of 3, and H of k values are given here. Now, what they've asked you to calculate or what they've asked you to analyze from the given question is they've given you two statements. They've asked you to find whether which of the given two statements are right, whether it is a low pass filter, whether it is a FIR filter, or it is both, or it is not both. So to analyze whether this is a low pass filter or a FIR filter, or if it is not, we will go ahead with the given statements in this manner. So these are the given values. So we will plot a diagram for this particular values and analyze how this actually looks like. Now, if you can see here, I've plotted the values here. Now, if you can look at the plotted values, every value of k has a finite, finite value, meaning the magnitude is finite, 0, 1, and minus 1. So as far as the given values look finite in magnitude, we could say that it has a finite impulse response. So if it has a finite impulse response, then it should be an FIR filter. And no way these values are pertaining to a low pass filter. So we could analyze that this particular impulse response corresponds to a FIR filter and not a low pass filter. So we finally conclude that statement 1 is wrong and statement 2 is right. The H of Z is a FIR filter and it is not a low pass filter. Next question. The Z transform of the sequence x of n is given by x of z is equal to 1 by 1 minus 2 z inverse whole square with region of convergence modulus of z less than, greater than 2. Then x of 2 is. So given question, they have given you x of z value and they've also given you the ROC and you'll have to analyze what is the value of x of 2. So for this, given we have taken as 1 by 1 minus 2 z inverse whole squared and ROC z modulus is greater than 2. So what we will do is we will expand this binomial by binomial expansion and we get it as 1 plus 4 z inverse plus 12 z power minus 2. So what we will do is in general, what is z transform x of z? X of z is equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. So x of n z power minus n, you will have to substitute values from minus infinity to plus infinity. Since it is given as z greater than 2, we could analyze that this is a right-handed signal. So right-handed signal in the sense minus infinity to plus infinity, the entire range we need not consider. It is enough if you consider only the range 0 to infinity. So if you substitute from 0 to infinity, x of n z power minus n. So substitute 0, x of 0 z power 0. Substitute 1, x of 1 z power minus 1. So comparing here, you will get it as x of 0. This is x of 1 z power minus 1. This is x of 2 z power minus 2. Then x of 3 z power minus 3, etc. So to obtain inverse z transform, your x of n will yield as this is your x of 0 value 1. This is your x of 1 value 4. This is your x of 2 value, which is equal to 12, etc. So from this given data, from this obtained data, we could see that this is 0th value, this is first value, and this is second value. So x of 2 value is 12. A system with an input x of t and output y of t is described by the relation y of t is equal to t into x of t. So this system is linear and time invariant, linear and time varying, non-linear and time invariant, non-linear and time varying. Um, so this question says that they have given a system with input x of t and y of t, which are described by this particular expression. So input-output relationship of a system is given here. You're asked to find out whether the given system observes linearity property and time invariance property, or if it doesn't satisfy both. So this corresponds to the topic properties of systems. So now we are actually what they have asked to analyze is they have asked to conclude whether the given system falls under linear and time invariance property. So any system which satisfies both linearity property and time invariance properties are called as LTI systems. So first, to check for linearity, we'll have to apply superposition principle. So if the superposition principle LHS and RHS are satisfied by the given equation, then this particular system will be set to follow superposition principle, and it is set to observe linearity. So first we will check for linearity and then we will check for time invariance property. Now, as you can see in the slide, now the given input-output relationship is y of t is equal to t in, sorry, this a into y1 of t plus transformation on a into y2 of t is equal to the entire transformation, I mean transformation on the entire signal, which is a into y1 of t plus a into y2 of t. We will have to prove whether LHS is equal to RHS. So for that, we will individually calculate LHS and RHS. So what we have here is first we will go with your LHS. So transformation A into y1 of t. So first guess what is A into y1 of t. What you'll have to do here is y of t is given in the question. Find out what is A into y of t. Then apply the given transformation. So what is the transformation in this particular input-output relationship? X of t is the input signal. So to the input signal, you're multiplying your entire signal by the time t. So that is the transformation here. So when you solve for system properties, you should be able to observe two things. One is you will have to individually able to identify what is your input signal. Input signal is always x of t. Then second thing is you will have to we will have to be able to understand what is the exact transformation which is applied to the input signal. So once the transformation is applied, you get you call the given signal as output signal y of t. So the transformation here is multiplying by the time t. So here, what you're asked to do for the LHS is you will have to create the signal A into Y1 of t and then apply transformation over it. First, what is A into Y1 of t? And then apply transformation to it. So in which case A t x1 of t will be your answer. Similarly, A y2 of t. You will get it as A t x2 of t. Now y1 of t and y2 of t are not two different signals. These are the same signals at two different time instants. So now calculate what is transformation on A y1 of t plus transformation on A into y2 of t. You will get it as these two values summed up. So if you take A as common here, you will get it as t into x1 of t plus t into x2 of t. This is your LHS. Keep it aside. Now we will go ahead with finding out what is RHS. So your RHS is transformation on the entire signal A y1 of t plus A y2 of t. So this you will get it as A into y1 of t plus y2 of t. So what is y1 of t? T into x1 of t. What is y2 of t? T into x2 of t. So multiplying this with the given value A, you will get it as this form. So if you can observe, both your LHS and RHS are the same. So thereby your system is linear. Second thing, we will check for time invariance property. So to check for time invariance property, you will have to make sure, you'll have to make sure that you are analyzing the LHS and RHS. First thing is you will have to delay the given input. Second thing, you will have to observe what will be the output for the delayed input. See, first thing you will have to check, you will have to obtain the delayed input signal. Second thing, if you apply the delayed input signal, what will be the observed output? Definitely it will be delayed. So that delayed output, you will have to get it. So first thing, you will have to delay the input. So delaying the input in the sense, the given question is, if you can see here, the given question is actually y of t is equal to t into x of t. So t into x of t. What is the input here? X of t is the input here. So you will have to delay the input. Delaying the input by any time period called t naught. So delaying the input means x of t minus t naught. So if you delay the input, you will get it as t x of t minus t naught. X of t is the input here. So you'll have to delay the input there. So it becomes t minus t naught. So if for this delayed input, what will be the observed output? So the output is then delayed. It will be of the form. To find out what is the delayed output, what you'll have to do is take the question y of t is equal to t into x of t. To find out the delayed output, wherever you have t, you will have to substitute it as t minus t naught. To find out delayed input, you will have to delay only the input x of t. To find out the delayed output, wherever you have t in the output expression, everywhere you will have to substitute it as t minus t naught. So it becomes t minus t naught x of t minus t naught. So if you can observe, this is LHS, this is RHS. Both the equations are not equal. So since they are not equal, we conclude that the system is time varying. It is varying with respect to time. So if you can see here, we have observed the system to be linear and we have observed the system to be time varying. So the right answer would be B. Now for the next question, let del of t denote the delta function. The value of the integral, my integral minus infinity to plus infinity, del of t cos 3t by 2 dt is 1, 0, minus 1 or pi by 2. So what they've asked you here is, they've asked you to calculate the value of this particular integral which involves a del function there. So we'll go ahead, integrate, substitute the value for this del and see what will be the value of this particular integral. So now del of t. Now this is a unit impulse function. So we know what is a unit impulse function. A unit impulse function value will be 0 for other values of t. For t equal to 0, its value may extend up to infinity. So we will make use of this particular statement, this particular property. Del of t into x of t can be called as x of 0 into del of t because it is existing only for t and not for any other values. Now your delta function, I mean your impulse function can also be defined as my integral minus infinity to infinity del of t dt is equal to 1. If you integrate your entire impulse function with respect to minus infinity to plus infinity, this will yield 1. So whatever is your given expression, you can take that x of t is equal to cos 3t by 2. So what we will do here is we will substitute in the given integral and we will get the value for this. So when you substitute your x of t in the given expression, so this is what you will yield as. So you will get it as x of t del of t dt integrating between the limits minus infinity to plus infinity. So this can be otherwise written as x of 0 del of t dt. So this is nothing but a del of t which is integrated between the limits minus infinity to plus infinity, whereby your value is 1. Now, the input and output of a continuous time system are respectively denoted by x of t and y of t. Which of the following descriptions correspond to a causal system? Y of t is equal to x of t minus 2 plus x of t plus 4, or y of t is t minus 4 x of t plus 1. Y of t is equal to t plus 4 x of t minus 1. Y of t equal to t plus 5 x of t plus 5. What they've asked you to find is they have given 4 input output relationships. So from this you will have to find out whether which of the given system is a causal system. Now, what is called as a causal system? A causal system has the output that depends only on the present and past values of the input. It does not depend on future values. If it relies on future values, then we call it as a non-causal system. So from the given options, we will have to find out which of these does not depend on future values. It should depend only on past and present. So in which case, if you can observe here, x of t minus 2 plus x of t plus 4. So x of t minus 2 is a past value. X of t plus 4 is a future value. So definitely option A is a non-causal system. Now, if you look at here, this is t minus 4 x of t plus 1. So you need not worry about this t minus 4 because that is just a time delay. I mean, that is just a multiplication of the time function. You'll have to observe this x of t plus 1. This is your input here. So you will have to discuss or you'll have to check whether this x of value is a past, future or present value. Now, if you can see here, this is x of t plus 1, which is a future value. So definitely this is a non-causal system. If you observe the last option, this is t plus 5 x of t plus 5. Now I've told you this is just a multiplication of the time factor. You need not worry about t plus 5 here. You will have to observe only this one, x of t plus 5. So this is given as t plus 5. T plus 5 pertains to future value. So then this is also a non-causal system. Now look at your third option, option C. If you look at here, this is t plus 4 x of t minus 1. Now I've told you, you need not mind about t plus 4 because that is just a multiplication of the time factor. You will have to think only about x of t minus 1. So x of t minus 1, your input is delayed here, meaning this is a past value. So this particular equation does not depend on future value. It depends only on the past value. So option C is the answer here. Option C is the causal system here. The next given question, a discrete time signal x of n is equal to sine pi squared n. N being an integer is periodic with period pi, periodic with period pi by 2, periodic with period pi squared, not periodic. So they have given you a discrete time signal and they have asked you to check whether this is periodic or aperiodic. If it is periodic, they've asked you to calculate what is the period. So a simple thing, we'll have to check for periodicity property for the given signal. Now, the given discrete time signal in the question is x of n is equal to sine pi squared n. Now, from this, you will have to obtain the angular frequency omega naught. So, sine is your function, n is your discrete instant of time representation. So, whatever is left over is pi squared. So, this is nothing but the frequency part. So, omega naught is equal to pi squared. So according to periodicity property, period n is equal to 2 pi by omega naught into m. So this m is an arbitrary value. So you can substitute any value for m such that n becomes an integer. Meaning you can substitute the values of m as 1, 2, 3, etc. So that this n becomes an integer value. It becomes a whole value and not a decimal value, because we really cannot have a period to be in decimal value. It should be a whole value. When do you call a signal to be periodic? If it repeats itself for a particular instant of time. If it repeats for n values, then you call a signal to be periodic. So n is equal to 2 pi by omega naught into m. So what is your omega naught in this case? Your omega naught is nothing but pi squared. So n is equal to 2 pi by pi squared into m. So which is equal to 2 by pi into m. Now what you will have to do here is, this m you can substitute any values ranging from 1 to 3. You can substitute any values of m such that this n becomes an integer. Now if you substitute 1, 2, 3 or any other value, definitely this is not going to become an integer. This is not going to become a whole value. This will yield only decimal values because you have pi in the denominator. So you could assume that this particular given equation, this particular given signal is an aperiodic signal. It doesn't have a period. Now, next question says, which of the following statements is not true for a continuous time causal and stable LTI system? Given are 4 different options. Now, these 4 options, you will have to find which is the correct option in order to fit for a causal and stable LTI CT system. Now, read the given options. All the poles of the system must lie on the left side of the j omega axis. Zeros of the system can lie anywhere in the S plane. All the poles must lie within modulus of S is equal to 1. All the roots of the characteristic equation must be located on the left side of the j omega axis. So here all the options are discussing only about the poles and the zeros location on the j omega axis. So we'll discuss which is the correct answer. Now, for stability of LTI system, all the poles should lie only on the left half of the S-plane, and there should be no repeated pole on the imaginary axis. So if you can see, option C will be the right answer, because option C will not be true for the stable system, because modulus of S is equal to 1 will have only one pole in the right hand plane. If you can look at this option, according to this option, there will be only one pole which is lying on the right hand plane. So then you can observe that option C is not true for causal and stable LTI system, whereas A, B, D, all the other options are true for a causal and LTI system. This is the last question for the session. Given are the two systems H1 of Z and H2 of Z are connected in cascade as shown below. The overall output Y of n is as same as the input X of n with 1 unit delay. The transfer function of the second system H2 of Z is. So what they are given you here is, you can see this picture depicted here. Now this is a cascaded system. There are two systems called H1 of Z and H2 of Z, and it is said that they are connected in cascade. So what they are asking here, what they are asking you to calculate here is, you will have to calculate the transfer function H2 of Z. So calculating the transfer function H2 of Z, they've given one more point here. The overall output Y of n is as same as the input X of n with 1 unit delay. See, you know what is X of n now, you know what is Y of n now, you know what is H1 of Z now. What is unknown to you is H2 of Z. So you'll have to calculate H2 of Z. H1 is directly given in the figure, you can see here. Now what is X of n and Y of n as told in the question? They have told you that you have an input called X of n, and what is your overall output Y of n? Y of n is as same as the input with 1 unit delay, meaning this input is delayed by 1 time unit, and that is your output. So what is your output? How can we write it as? Y of n is equal to X of n minus 1. X of n is your given input. So time delay it by 1 unit and you get it as X of n minus 1. So the point is very simple here. Yesterday when we discussed the problem, we discussed one such problem for cascaded system, and I've told you that for a cascaded system, your entire H of Z, your overall H of Z will be H1 of Z into H2 of Z. Look at here. Your overall H of Z, your overall transfer function of the system would be H1 of Z into H2 of Z. So we will make use of this given expression to calculate H2 of Z. So what actually we'll have to do here is, H of Z is equal to H1 of Z into H2 of Z. You know what is H1 of Z, which is already given in the question. H2 of Z we do not know. H of Z we will be able to calculate easily from the given Y of n. So first calculate H of Z and then substitute it here. Now Y of n is equal to X of n minus 1. Take Z transform on both sides. So you will get it as Y of n will become Y of Z. X of n minus 1 on Z transform will give you Z inverse X of Z. So bring it as Y of Z by X of Z, which is equal to Z inverse. So what is Y by X? Transfer function H of Z is nothing but Y of Z by X of Z. So H of Z is nothing but Z inverse. So substitute your H of Z in the given expression. For a cascaded system, H of Z is equal to H1 of Z into H2 of Z. So substituting your H of Z, Z inverse is equal to 1 minus 0.4 Z inverse by 1 minus 0.6 Z inverse into H2 of Z. So what is your H2 of Z here? Simply cross multiply and obtain your H2 of Z as Z inverse 1 minus 0.6 Z inverse by 1 minus 0.4 Z inverse. So this is how you get your second transfer function. Sorry. So that is how you get your second transfer function H2 of Z. So with this, the entire presentation for signals and system for my part is over. Next, This session is officially over. We request you to join with us tomorrow at the same time for more questions on signals and systems, gate problems, which is to be solved by another faculty. Thank you, everyone. The session is officially over. People can take a leave. All the videos, all the recorded videos will be available in our YouTube channel, Learn with Us. For any queries, please post to sttpec@gmail.com.